Hey guys, John Grimsmo here. Welcome to another Knife Making Tuesday. It got cold again. It's the end of October up in Canada, and it got cold. Kind of snuck up on me. I've been in this garage for 5 years now, 5 winters, and I haven't had any heat or any insulation. And I've been telling myself for a couple of years now, but especially this year, I'm like, this year I am spending the money to insulate this place and put a nice beefy heater in here. And I will, I just haven't done it yet. Like I said, winter snuck up, so that'll be a project hopefully in the next few weeks. Nice insulation everywhere and heat, and I don't need this and I don't need this, and I can just come out here and be comfortable and warm and work. Yeah, so that's that. For this week, I really don't know what I'm gonna do yet, but I've got got one thing in mind, and then we'll see where it takes us from there, but I'll show you guys some stuff. So one thing we've been working on lately is 1 or 2 or 122 Norseman blades. I think literally this pile of blades is equal to the amount of Norsemans that I've sent out so far. Which is pretty cool. Yeah, I believe there's 122 blades here. And we're just processing them right now, getting them ready to send out to heat treat. There's a local heat treat place about 50 minutes away that they do aerospace parts, and they can vacuum heat treat these and then cryo treat them, and the price is really affordable, and it's just I'm pretty happy with how that's turning out. So for big batches and stuff, it's obviously the way to go. So because of the way that I manufacture these blades, I use the CNC mill to machine the bevels onto each side. There's a few guys doing it that way, but not very many, so it's kind of a unique thing. And it's become my signature. These milling lines, that's what the Norseman is. However, machining it like that causes the blade to warp a little bit. So you machine one side and it warps. I forget if it warps up or down, and then you machine the other side and it pretty much brings it back to center, but not exactly. So the blades, if you look at them dead on, they always have a bit of a kink to them. Mostly in the same direction, but sometimes one will go the other way and some will go some way. So right now I'm in the process of straightening them. So machining them brings a little kink to them, and then heat treating also has the potential to bring a little kink to them too. So the straighter they are going into heat treat, the straighter they are going to be coming out of heat treat. At least that's my theory. Up until now, all the knives we've sent out, we pretty much just machine them, Scotch-Brite the edges and stuff because it's easier when it's soft, and then send them off to heat treat. And they come back, a little bit warped because I didn't straighten them before heat treat. So the first question is obviously, how do you know if it's straight? Well, you can look at it. You can look at it straight on, and sometimes you can tell if it's got a bit of a kink to it, but that's not the best way to do it. It's too vague, and just not that accurate. A couple weeks ago, Eric and I went to a surface grinding shop. They specialize in surface grinding, double disking, lapping, Blanchard grinding, everything. And it was really cool to take a tour of their shop. I wish I had the video camera. And have the guy explain to us how everything works and what surface roughness, surface finishes are, and all kinds of information that was just really interesting to know. And I brought some blades with me just to demonstrate, and he actually measured a few of them for flatness, and I'm going to show you guys how he did it. Now keep in mind, I never went to school for machining or measuring or anything like that, so everything I learn is new. I have to learn it to know it, or teach myself or have somebody tell me. So I never really thought about doing it this way, but here I've got a magnetic base with an attachment, and this is a dial test indicator with each graduation is 5/10 with I think a 15,000ths sweep either way. And he had something similar to this, just way higher quality stuff, of course. This is a countertop, like a granite countertop, left over from some family member brought it over when they were building their counter. So that's cool. It's not the most flat, perfect, even surface. There's pits in it if I drag my fingernail on it, but it's a starting point. The big shops have these granite, epoxy granite tables that are super flat and perfect. And now, because the surface of this is a little pitted, I sprayed a little bit of WD-40 on it so that this will slide easier. That seemed to help a lot. But the theory is you lay your blade down flat, you don't touch it. Okay, basically you adjust the height of this so that you get some preload on the dial test indicator. And then you sweep it across. Measuring the whole blade for warp. And then you can sort of go to every corner and measure if it's warped and where it's warped, where it's high, where it's low, and stuff like that. Seems to work okay this time. The first time I did it, I wasn't very happy with the results. Right now it seems to be working alright, actually. But maybe it's because my table's kind of sticky and bumpy and not perfect, and the blades are a little bit warped. I'm finding the readings to be very erratic and very hard to read and be consistent. Maybe I'm not giving it enough time to learn this process, which is very true. But I found this kind of time consuming, especially for the purpose that I'm using it for right now. So I found a better way, a quicker way to do it that I think works fine for me. So the reason I'm not super duper enthusiastic with how this is working for me, very common in machining, and you buy it, it's basically surface ground to an exact width, an exact length, and an exact thickness. This one has been surface ground to exactly 1.500. So I know it's flat, I know it's parallel because it came from the factory like that. It's designed to be perfect like that. If I put this down and measure it with the tool, I mean, I'm not doing a very good setup here, but if I swing it across, okay, that actually read alright, but last time I did it, it was varying a lot. Regardless, it's a time-consuming method, and I don't know, I just didn't love it. Maybe I need to give it more chance. But my way, much easier, much faster. I know that this is flat, so I lay this up here. With a knife, you know, when it's fully assembled, the only place on the blade that's being held by the knife is the pivot. And a little bit of side pressure from the lock bar because it's spring-loaded. But the pivot is the only place that's being held. It's not being held in the middle or at the tip or anything like that. So I lay my blades down on the parallels, and I use my finger and I hold it on the pivot, similar to how it will be in the knife, and then I just hold it up to a light source, so I can get a backlight, and then see if there's a gap. If there's a gap in the middle, it's bowed this way. If there's a gap at the tip, then it's bowed up. And then I can easily bend it and flip it and test it, and it's a really fast, visual way to do it. And I kind of like doing it this way. Not perfect, not ideal, but I'm just trying to get them close before heat treat, so that a quick, very light surface grind after heat treat will make them nice and flat. So today it's kind of cloudy and miserable outside. Yesterday it was way sunnier, but let's see if I can do this. Alright, first let me look. Okay, I can kind of see. There we can see a gap at the tip. You can see daylight through the tip there, just a little bit. It's hard with my camera light, so I'll turn that off. There we go. Alright, if I hold that down, there, we can see daylight. That's a little bit. And then if we flip it over, should be a gap in the middle. Yep, and it's touching at the tip, you can see right there. And there's a gap in the middle. So I know that this blade is now warped like this, and I'll show you how to bend it. So this is 1/8 inch high carbon stainless steel. RWL34 is the name of the steel. Pretty tough stuff, but in the soft form, I think the Rockwell hardness is in the 30s or something, whereas after it's heat treated, it'll be 60 or 60.5 or so. So it's actually relatively soft as it is right now. And I've already forgotten which side is the high side. Alright, that's the high side. So going this way, I know that the blade warps up a little bit, so if I push it like that, it'll counteract the warp up, and it really doesn't take a lot of effort. I was actually very surprised. If I just go like this and just put some weight into it for a few pushes, then that'll bend it. So doing it like that will actually bend it, and we're only trying to bend it a few thousandths of an inch at most, so it doesn't take a lot of effort. So now I'm going to test it again. Okay, it's still high on that side. As often as possible, try to make sure your surfaces are clean, your blade is clean. That way any dirt or grit doesn't get, under the surface and mess up your readings. So, not putting a ton of effort, a ton of weight into it, just a little push. A little bit more. I'd say maybe half or a third of my, body weight, my upper body weight. Getting better, and I'll flip it over, test it again. See, now, the way that I see it right now is doing it one way, there's a little bit of a gap on this tip of the blade, and then when I flip it over, there's the same tiny bit of a gap on this side of the blade. So, yes, it does seem to warp up, but it warps up evenly on both sides. So that must mean maybe there's a tiny burr or something like that, but it's even on both sides, so I can assume that it's straight enough. Some of them end up flat, so that there's no gap throughout the entire blade on both sides. That's perfect, but for this purpose, close enough is as good as I'm going to get before heat treat. Also, with these blades, I buy them as 1/8 inch. They're maybe 0.126, which is just 1/1000th over 1/8 inch. A lot of guys, they buy their steel quite a bit thicker, so that before they even mess with it, they surface grind it down to a some sort of a thickness, and then they grind or machine their blade, and then they surface grind it again soft, so that it's perfectly straight going into heat treat. I don't have hardly any room to work with on these blades because they're already so thin. So at most I can take off 1/1000th per side. So I'm trying to keep it as straight as possible going into heat treat, so that coming out I can just take off 1/1000th per side, and then hopefully it's good enough. So also we make sure to deburr the stop pin groove, the pivot hole, the thumb stud hole, all the jimping on the outside, because sometimes the machining operations, if the end mills aren't perfectly sharp, then they'll leave a burr on there. So we just give a quick Scotch-Brite on those surfaces to make sure that they're flat and smooth and don't catch a fingernail or anything like that. Otherwise they will mess up this kind of reading. But yeah, so that's how I'm spending my morning today, straightening my blades, and just write a little S on each one that gets straightened so that I can keep them all straight. And then I'm hoping to ship them off to heat treat today. Well, there's one more thing I wanted to mention about the straightening procedure. This is relatively new to me. I'm learning it as I go. I'm doing my research online. I'm asking grinding shops. So there's a very high probability that I don't know what I'm doing and I'm doing it wrong. If you're out there and you have a better suggestion for me, please, by all means. That's kind of why I do these videos, so that I can tell you guys how I do it. I'm not saying it's right, not saying it's perfect, but this is how I'm doing it right now. And if you have any suggestions to help me make it do it better, please, I'm all ears. That's what the comment section is for. It helps me learn. I throw out my ideas, good, bad, or ugly, and get back a lot of positive feedback. So, yeah, just keep it positive, and if you can help me out, that'd be awesome. But for now, I think this way works fine. So the other thing I wanted to mention about straightening, now that I remember, is once the blade has been heat treated, you can bend it, not with your hands like that, but with like an arbor press, but it's got a really good memory. So, if it's got a little bit of a warp to it, you can bend the warp out, but then it just springs right back. And it's very springy, and it's very difficult, if not even possible, to bend the warp out of a blade that's already been heat treated, because it'll just spring right back. And if you go too far, it'll snap. Ask me how I know. Ask Eric how he knows. So we did that in a video, the Tormac video. While the blade's still warm, Eric's going to go over here to the arbor press.
Pretty straight.
So Eric's just trying to figure out if it's warped or not.
It's going to take a lot out.
It might be a little bent this way.
I mean,
if it doesn't rock, it ain't bent.
the word is a folder blade has to be exactly straight. A fixed blade has to look straight.
Look straight to you?
Dude, I can't trifocal. Man, no.
So just gentle.
Yeah, so.
It's spring steel, so it's springing back.
Yeah. So we didn't get it on video, but
You didn't get that on video?
no, but Eric snapped it in half.
These guns, they just... I'm not blade straight enough.
Was this the chin-up bar you were talking about?
Let's see. Yeah, so that's why I'm trying to get them as straight as possible before heat treat, so that I don't have to bend them, because I can't, after heat treat. And that way, when I surface grind them afterwards, I'm just taking off a tiny little bit to account for any kink or warp, not like a huge amount. Because then you're taking, you know, a banana down to really, really thin, and it just doesn't work that way. So that's why. So for these inlay knives, I'm not sure off the top of my head how many I've made so far, but, you know, a dozen or two, probably 2 dozen. So I make these inlays out of all different materials, carbon fiber, wood. These happen to be G10, black G10, and they're slip fit. Some of them are a little bit tighter than others, but this one just happens to fall right in. And then they're glued in. Normally I use Loctite 324, which requires an activator, a 7075 activator. And that seems to work really good. One time I was in a rush, so I just used Gorilla Super Glue and I forget if I used the Instaset, the hardener, the quickener, in case your super glue isn't super enough. But I glued in a set of micarta inlays like that, kind of last minute at a show, and then I delivered the knife to a guy, and he said after a few weeks one of the inlays popped out. Now, it was no big deal, he was totally cool with it, but he just wanted to know if he could fix it himself. So I said, sure, clean it up really good, you know, scrape down to clean metal, make sure there's no extra junk in there, and then get some more super glue and try it again. And if it pops out again, then we'll try something better. But so it got me thinking if there's any way I can increase adhesion with the inlays. And the first thing that came to my mind is to basically go like this. So to do that, all I did was I take a Dremel with, this is an old carbide end mill, 3/32 ball nose, which is not so much of a ball nose anymore, but I was able to screw the handle to my sanding block here so that it's tight, put the whole thing in my vise so that I don't have to worry about this jiggling, and then I just hold the Dremel really steady and then just buzz a pattern in. Obviously you do not want to miss and hit the pretty part of the handle. Luckily I was okay with this one, but kind of worried that that might happen in the future. I could code something like that with CNC, and after it cuts out the inlay pocket it could mill some sort of pattern to increase adhesion. It just gives the glue more places to go, more surface area to attach to. You know, making it a little bit rougher just gives the glue a better chance of sticking. That's my theory anyway. But yeah, that's kind of what I'm working on right now. Another thing we've got going on here is all the screws that we use for our knives, they start out this long, but they need to be this long. So they're about twice as long as they need to be. These are stainless screws with a T10 Torx head, really high quality stuff. But they're too long and I can't get them in the 1/4 inch or the 1/8 inch length that I need. Like, I really like these exact screws. So to shorten them, we do something like this. I think I've showed this in previous videos, but This is just a scrap piece of RWL blade steel that we drilled and tapped a whole bunch of holes in. So the screws go in like that, and then we throw this in the mill in a vise, and it'll just take an end mill and chop everyone off to the right height. And then we can Scotch-Brite the tips off to get rid of the burrs. That seems to work pretty good. This was a really quick proof of concept made like over a year ago. And now that we know it works, I could easily make a bigger piece of this and do a lot more at once. So there we have it. So this is the bag of screws that we got. There's like a few thousand in here that eventually we need to get through and shorten. So having a bigger sheet would certainly help.